Okay, today we'll solve a few problems related to inverters. We already discussed inverter single phase and three phase. So let me start with the first problem here. Okay, you can see there are many information given the question. It's not necessary you use all of them. Use whatever related to the objective or subject you want to solve. Let me read it carefully here. Have a look. He told me there is a push-pull inverter. I know push-pull inverter, the one which have two switches and center tap transformer at the primary, is to be designed with the following specifications. He told me that the input voltage is 48 and the output voltage is 5. This is a step-down converter, push-pull. Frequency of the switch is 100 kilohertz. We always expected that the frequency will be high in kilohertz. And the load power is 100. Transformer turn ratio N1 to N2 is 6:1. Now he told me that assume all components are ideal except for 0.25 forward voltage drop across each of the switches. Okay? It means when the switch conducts, the output will be input minus this drop. Or in another way, input equal output plus this drop. What duty cycle D will each switch operate when the switch operate when V input is 48? He told me find the duty cycle. I will say, okay, very simple. Output plus the drop across the switch, because as I mentioned, he told me in the question, consider voltage drop across the switch when it conducts. So these together represent the input times duty cycle. Definitely I need to multiply by the ratio. Okay, this is step down converter. Let me see. Do I have output voltage? Yes, he told me it's 5. Do I have forward voltage drop? Yeah, he gave me 0.25. Did he give me the ratio? Yes, he told me that the ratio is this. Did he give me V input? Yes, he gave me V input, which is 48. Okay. Can I? Okay. So what we will do, we will substitute to find D. I found D. It was found to be 69. It means 0.69. 69% of the time, the switch will conduct. Okay. Now let me ask a question here. How many switches in the circuit? 2, right? 2. So it means I need to divide this value by 2 because each one of them will conduct half of this time, half of the duty cycle. Now, this is the first point. The second point, he told me what is the average current which flow in each switch at full load. Okay, he told me that the power is given 100 watt. So if I divide 100 watt divided by 5, which is the output voltage, it gives me the current. This is the output current. Now again, this current to be conducted by the switch, regardless if it's switch 1 or switch 2. But if we want to calculate the average, since each switch conduct half of the time, then I need to divide 20 by 2 to say that this is the average. So I got the second point. Third point, what is the approximate maximum voltage experienced by the switch in this circuit when Vn is 72? If Vn is 72, the switch can block how much? What is the voltage can be blocked by this inverter? Just let me remind you. Push-pull inverter. Anybody remember how much the voltage will be in push-pull? Anybody? Double the voltage, right? You remember? Double the voltage, we say. We say it is double the voltage. So it means multiply by 100 by 2, it will be 144 volt, double the voltage. And explain the change would occur in the switch voltage rating if a full bridge inverter topology was used. Now, if we use full bridge, how much the blocked voltage? What do you think? VD, only VD, 72. You see?
72.
Yeah. So only in push-pull, the voltage to be plugged by the switch will be double the voltage. Now this problem related to push-pull, okay? Now I will skip this problem because it's similar to the one we discussed in the session. I mean, just half a bridge or full bridge, it doesn't matter. We just need to substitute by the switch utilization ratio. We have the formula, just we substitute it, and then we can come up with the switch utilization ratio. But I will go to this one. In a single phase square wave, now it's not pulse width modulation, it's square wave inverter has a resistance, the load is 2.5 ohm, and the input voltage of 50, input voltage is 50. Okay, calculate the following. The output voltage occurred at the fundamental frequency. Now, you remember what we say? We say that for a square wave, VAO1 will be equal to 4 over pi VD if it is full bridge. If it is a half a bridge, VD over 2. You remember? We discussed this. By the way, he's supposed to tell me here that this is half a bridge. He didn't mention, but I supposed to write here half or half bridge. So you can use this formula. Otherwise, if it is full bridge, only VD. So as you can see here, 4 over pi is 1.273. VD, sorry, okay. VD is given in the question, which is 50 here in the question. Then I divide, this is the voltage. Now the second point, he told me calculate the power output. Okay, output power. Okay. Now I will come, output voltage is already calculated. Okay. Output power will be V square over R. You have V, you have R given the question, directly you got the power. Last point is peak current and average current at the input. Peak current is peak voltage over the resistance. We assume that there is no losses in the circuit. And V input is 50 given in the question, divided by resistance, it gives me the current. If I want to find the average, I will divide by 2 because I have 2 switches. So it will be 10 amp. Now, the last problem is exercise for you. I gave you the key answer. You just need to try it. It's easy. You can use the formula in the lecture notes, in the lecture